Right now, somewhere, a platform engineer is deep in a spreadsheet comparing bin packing strategies, saving maybe 2% on compute while burning 40 hours of engineering time. That math never works out. The cloud bill drops a little, the team slows down a lot. And here's what nobody tracks. Every tactic you bolt on adds configuration surface area, more things to break during upgrades, more runbooks to maintain at 3 in the morning. There's a threshold where optimization stops saving money and starts costing velocity. We're going to show you exactly where that line is. Think about what a senior engineer costs per hour. Now multiply that by the dozens of hours your team spends tweaking node affinity rules or fine-tuning bin packing configs that shave off maybe 2%. That's not optimization. That's a money pit wearing a cost savings label. And it gets worse. Every custom config your team builds becomes something they have to maintain. When it breaks at 2 in the morning, someone gets paged. When a new Kubernetes version drops, someone has to verify it still works. The cloud bill might shrink by a few $100s a month, but you're quietly hemorrhaging thousands in engineering capacity that could be shipping features your customers actually need. Stop and actually look at this. Not as a checklist, as a filter. The column that matters most isn't savings. It's operational cost. Because a fix that saves 20% but requires a dedicated engineer to babysit it? That's not a savings. That's a new hire disguised as infrastructure. Rightsizing sits at the top because it's the highest return for the lowest ongoing effort. You run one analysis, adjust your resource requests, and the savings compound every month without touching it again. Spot instances save more, but only if your workloads can handle interruptions. Stateful databases? Don't even think about it. The whole point of this framework is to stop your team from treating every optimization like it deserves equal attention. Some of these fixes take an afternoon, others take a quarter. Know the difference before you start. Every engineering team has that one deploy where someone panic set the CPU request to 4 cores because of a traffic spike 18 months ago. Nobody ever turned it back down. That's how over-provisioning happens, not through bad decisions, but through reasonable decisions that nobody revisits. Here's what makes this the single highest leverage fix on the entire list. You're not changing architecture. You're not migrating workloads. You're just closing the gap between what you asked for and what you actually use. And that gap is enormous. Most services are burning budget on capacity that sits completely idle every hour of every day. The fix is almost boring. Pull 2 weeks of observability data. Look at actual CPU and memory consumption across your services. Then adjust your resource requests to match reality with a reasonable buffer. Do this once a quarter. That's it. What makes this powerful is the math. If your cluster is running 50 services and each one is over-provisioned by even 50%, you're paying for 75 services worth of infrastructure. Trimming that back doesn't require a platform initiative or a 6-week migration plan. A single engineer can knock this out in an afternoon with the right dashboard. And unlike most optimizations, there's almost zero operational risk. You're not removing capacity anyone was actually using. Cloud providers have spare capacity sitting idle at any given moment. Rather than let those servers earn nothing, they sell them at a steep discount, but with a catch. They can pull them back with as little as 2 minutes notice. That sounds risky until you think about what actually happens when a stateless service gets interrupted. A load balancer is already routing traffic across multiple pods. One pod disappears? The others absorb the traffic instantly while Kubernetes spins up a replacement. The user never notices. Compare that to a database. If you yank a database node mid-transaction, you're looking at data corruption, recovery procedures, and a very bad afternoons. This is why the stateless distinction matters so much. Your API servers, your background workers, your batch processing jobs, these are all designed to be disposable. They hold no local state that can't be reconstructed. That's exactly the profile spot instances were built for. The practical move is to run your baseline capacity on reserved or on-demand nodes and let spot instances handle everything above that baseline. When traffic spikes, you're scaling on nodes that cost a fraction of the price. When the cloud reclaims them during quiet periods, you don't care. Demand already dropped. Teams that get this right often find Spot becomes 70 to 80% of their total compute. That's not a minor optimization. That's a fundamental shift in your cost structure. Two tools doing the same job sounds like a safety net. It's actually a trap. Karpenter watches your pending pods, then provisions the exact instance type down to the CPU architecture that fits the workload. Cluster Autoscaler takes a simpler approach. It looks at node groups you've already defined and scales them up or down. Both get pods scheduled. Both keep your cluster right-sized. The problem starts when a team adopts Karpenter for new workloads but leaves cluster autoscalers running on legacy node groups. Now you've got two systems fighting over the same capacity decisions. One scales up a node, the other decides it's underutilized and tries to drain it. Engineers burn hours debugging phantom scheduling failures that neither tool caused on its own. We've seen teams report 10 to 25% compute savings just from eliminating that conflict and letting one system own the scaling logic end to end. The decision tree is straightforward. If you're all in on AWS and want instance-level flexibility, Karpenter. If you run multi-cloud or want the simplest possible setup, Cluster Autoscaler. What matters isn't which one you choose, it's that you actually choose. Migration has a cost, yes. But that cost is a one-time investment. Running both is a recurring tax on every engineer who touches infrastructure. Picture your infrastructure like a restaurant kitchen. Without autoscaling, you're staffing 30 cooks around the clock, even at 3 in the morning when nobody's ordering. That's what fixed pod counts do to your bill. The horizontal pod autoscaler watches your actual traffic patterns and adjusts in real time. When your lunch rush hits, say a product launch or a marketing campaign drives a spike, HPA spins up more pods in seconds. When traffic drops after hours, it scales back down. You stop renting capacity that sits idle for 16 hours a day. But here's where most teams leave money on the table. They set conservative thresholds, targeting 40 or 50% CPU utilization because they're afraid of latency spikes. That fear is expensive. The sweet spot sits much higher. When you target 70 to 80% utilization, you're running your pods the way cloud providers intended for burstable workloads. Hot enough to be efficient, cool enough to absorb sudden jumps. The part that trips people up is scale-down behavior. HPA scales up fast by default, but it's deliberately slow to scale down. There's a 5-minute stabilization window built in. If you don't test this in staging, you'll wonder why your overnight bill doesn't drop as fast as your traffic does. Tune the cooldown, watch the metrics, and validate that pods actually terminate when demand falls. That's where the real savings hide. Not in the scaling up, but in the willingness to scale back down. This is the fix that feels the least exciting, but might save you the most money long-term. Here's the logic. Look at your cluster usage over the last 90 days. Strip away the spikes, the product launches, the traffic surges, the end-of-month batch jobs. What's left is your floor. That baseline compute is running 24/7, whether you reserve it or not. You're already paying for it at full price every single month. Cloud providers will give you a massive discount, 30 to 60%, just for promising you won't leave. It's like a gym membership versus paying per visit. If you go every day, the membership wins by a landslide. The key insight most teams miss is what not to reserve. Only commit to your floor. That burstable traffic on top, that's what spot instances and auto-scaling handle. Teams get burned when they reserve capacity for their peaks instead of their baseline, then end up paying for idle reservations during quiet periods. Start conservative. A 1-year commitment on 70% of your observed floor is safer than a 3-year bet on what you think you'll need. You can always add more reservations next quarter. You can't cancel them early.